summarize what you should have seen. Okay, so these all here were the problems that you graphed in this page and the page prior. Okay, so some of this stuff doesn't have anything to do with the graph. It just has to do with how we're going to end up finding the asymptote. Some of you noticed it already, I think. Okay. So the leading term in the numerator, meaning the leading coefficient, would be this right here. Okay, so that's 3. The leading term in the denominator would be what's in front of the highest term, and there's nothing written there, so what can we put? 1. Okay. What's going to go here is I'm going to put the, well, you're going to see like what kind it is, but it has something to do with a 3 and a 1. Did anybody find the horizontal asymptote for the one on the first page? And if so, what did you find? Looks like when we've graphed it, the horizontal asymptote was y equals 3. Okay, so and I'm going to point out to you what the degree of the numerator and the denominator are. So this is the degree of the numerator is 1 and the degree of the denominator is 1. That's what we're going to get to in a second, what it has to do with. Okay. So leading coefficient in the numerator here, this is an x squared, is 4. The leading coefficient in the denominator is -2. And the equation you should have gotten for the horizontal asymptote for this one was y equals -2. Leading coefficient in the numerator here is 2. What's the leading coefficient in the denominator? 1. The horizontal asymptote you got here was y equals 2. All right, I'm going to kind of draw a line here because A, B, and C are kind of a group together, and I'm going to tell you why. Do you see here how, let's now look at the degree. The degree of the top is 1 and 1. The degree of the top is 2, degree of the bottom is 2. The degree of the top is 3, the degree of the bottom is 3. So what's true in all three of those about the degree of the numerator and denominator? Yes, they're the same. So what we're going to write here is there's not enough space. Degree of the numerator versus degree of the denominator. And in all of these cases, they are equal. Okay. So when you're looking for the horizontal asymptote, that is one thing you're going to figure out first. If the degrees are equal, does anyone see a relationship between these two columns and what we get here? Is there any way you can do something with these two numbers and get the number here? Divide them. Isn't 3 divided by 1, 3? Isn't 4 divided by -2, -2? And isn't 2 divided by 1, 2? So and we are going to write, don't worry, we're going to make a foldable today. When we have the degrees that are the same, you're going to literally take the leading coefficient divided by the leading coefficient. And that's going to give you a horizontal asymptote. Okay. All right, next kind of category. Let's look at D. This is a 1. This is a 2. The degree of the numerator versus the degree of the denominator. Okay. What's the degree in the numerator? 1. And the degree in the denominator is 2. They are not equal anymore. Agreed? So I'm going to say degree of the numerator is less than the degree of the denominator. Okay. Did you guys do D? I need somebody to help me on this. Did anybody do this one? This one was D right there, I'm pretty sure, right? Did you get to that? Kimberly, did you get to that one? What did you think the horizontal asymptote was of that one? What was your guess? You were right, okay? She said she put 0, okay? So this had a horizontal asymptote of y equals 0. All right, now E. I'm going to point out to you again, the degree of the numerator is 2. This is 3. Let's write down the leading coefficients. We have a 2. We have a 1. This is less than that. This should have also been equal to 0. Okay. In this case, okay, this is kind of my middle section. In this case, do these relate to that? Is there any no? Okay. When the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is going to be y equals 0. You don't use any numbers. And here's why. It has to do with number sense. Okay? Think of a fraction, guys. Let's say I had a fraction, and would you agree if there's a higher degree on the top, the bottom of the fraction is going to grow faster than the top? Is that making sense? Okay. So just let's play around with this a little bit. If this was like 10 and this was 1,000, what's 10 divided by 1,000? It's 0.01. As this continues to get bigger and bigger and bigger and bigger, this number is going to get smaller and smaller and smaller and smaller. That's why it approaches 0, because the bottom of the fraction is growing. Okay? Way faster than the numerator. All right. F and G. Leading coefficient here is 2. Leading coefficient here is 1. Let's look at the degrees. Do you see that the degree of the numerator this time is bigger than that of the denominator? Okay. This had none. There was no horizontal asymptote. It kind of went off, up and to the right, and then down and to the left. So this one, same deal. This was a -3 and a 1. The numerator is bigger than the denominator, and there was none. Now, I'm going to show you something cool today. Some of you aren't going to think it's cool, and that's fine, because I'm a math teacher, and I think different things are cool, because I'm a math teacher, and that's just, we think weird things are cool. Some of you are going to think it's cool. There is a way to find this angled asymptote. I'm not assessing it, but I'm going to show you how to find it. Okay? These two things you should know. You should know how to find the horizontal asymptote. All right. Use your findings from the table to write an equation for rational functions that satisfy the following. Okay. If something has a horizontal asymptote at y equals -5, I would need to have the same degree on top and bottom. Brian, give me a degree, just any degree you want. Okay, so what I would have to have is, like, I'm going to make something up. X to the 4th plus 3x squared plus 1. On the bottom, I'd need an x to the 4th, I don't know, plus 5x minus 2. In order to make this have a horizontal asymptote of -5, I would need the leading coefficients to divide to be -5. What would maybe I want to do then for that? Could I make this -5 and this 1? Would that work? Yeah, or you could make it like -10 and 2, or 10 and -2, something like that. All right. What if something had a horizontal asymptote of y equals 0? This time, I need the degree on top to be less than the degree on the bottom, okay? So Zoe, pick a degree for me. 2. So if let's say I made the top degree 2. So x squared plus 7. I'm just making things up. Now I'd need to make the denominator bigger. So Kimberly, pick something for the denominator. A degree. Yeah. Okay, degree 2 is smaller than degree 6. That would work. Okay, there's not enough room here. How about something that doesn't have a horizontal asymptote? What would we need to do? Degree's got to be bigger on top. So make something up that has a degree bigger on the top. I'll put it over here. So maybe it's something like x to the third plus 7x plus 2, but on the bottom I have x minus 1. Okay, that would be something that has no horizontal asymptote. Okay, now, one thing to note, because some kids were asking me this in 6th hour. They asked me, well, Miss Comrie, how come you said it has a horizontal asymptote, but it crosses it in the middle? Did anyone notice that yesterday, that it crossed in the middle? Even the one we just did? All right, do you see that in the middle here? Do you see how it crosses it? Okay, but then at the ends it does not. So is it possible for the graph to cross the horizontal asymptote? Yes, in the middle it is, but not at the ends, okay? We sometimes call it in math an end behavior asymptote because it doesn't cross it at the end. So in looking at the little part on the back then, can a function cross a horizontal asymptote, why or why not? Yes, in the middle. And the reason why is because it describes the ends of the graph. Okay. So what are the differences between horizontal and vertical asymptote? Well, duh. First of all, one's a horizontal line and one's vertical, right? That's pretty obvious. Also, vertical asymptotes, it will never cross. So it's going to never cross here. Sometimes in the middle it will cross that. How can one find the horizontal asymptote of a rational function given its graph? We look at the degree of the numerator versus degree of denominator. I don't want to write all this separate for, that's really the big deal, denominator. I'm going to just put that for all of these. Because sometimes on a graph it is a little bit hard to tell. So we're going to look at a function. We're going to look at the degree of the numerator and denominator. We'll do an example in a second. And that is the best way to tell the horizontal asymptote. Okay.